Hello, today we are talking about the stages of sleep and our sleep cycles. Sleeping is a natural behavior that all human beings have to do. It is part of being healthy and is one of the pillars of health. Often we talk about eating right and exercising, but the part that we often don't really emphasize is the fact of uh, good quality sleep. And that's the key term here is quality over quantity. And today we are looking at the various stages of sleep that we go through every night, or at least hopefully every night, and getting a good night's sleep. So, first of all, we use an EEG or an electroencephalogram in order to study sleep and sleep patterns. An EEG is going to be able to measure the amount of brain activity that takes place at any given moment. And for a long time, we didn't even think anything really happened when we were sleeping, just that, we had these occasional bizarre dreams, but nothing else besides that. When almost by accident, a person fell asleep while wearing an EEG, and we discovered that our sleep is actually very interesting, and that while we sleep, we go through these different stages of sleep. And we know that, of course, by the size and shape of the wave that takes place while we are sleeping. So, right now, hopefully, you are awake. And if you were awake, we would call this a stage zero. You're currently in stage zero, meaning, of course, that you're not sleeping. And that if you were hooked up to an EEG, you would be producing alpha waves because when you are awake, you produce alpha waves. But now, if you were to shut your eyes and relax, after a little bit, you might drift off into sleep, and you wouldn't even be consciously aware of the fact that you drifted off to sleep. It would just be a change in the amount of brain activity, and that your brain would, of course, begin to slow down. And at that point, you will have entered what's known as stage one sleep. And in stage one sleep, you can see that the alpha waves are pretty short. That's because they're happening rather quickly because you have a lot of brain activity. The waves of stage one sleep are going to be known as theta waves. They're still pretty small and they're also pretty irregular because during this stage of sleep, these theta waves, it's going to be very easy to wake a person up if they're in stage one sleep. In fact, if they were to wake up, they would probably argue that they weren't even sleeping, that they were just, daydreaming or something like that, when in fact they have indeed fallen asleep. Now, the amount of time that a person stays in this stage one sleep is entirely dependent on how exhausted their mind and body is. Whereas if I'm really, really tired, when I close my eyes and I begin to fall asleep, I'm only going to be in this stage one sleep closer to this 30-second mark. Whereas if I'm not as tired, if I'm not, as exhausted, I'm going to stay upwards to about 10 minutes or so in this stage of sleep where really my body's pretty relaxed. My mind is starting to calm down, but it is still, in fact, pretty active, and I'm producing these theta waves. If you're at all familiar with the sensation of you're falling asleep and then you kind of jerk awake and your body jerks and you find yourself waking up, that's taking place in stage one sleep. In fact, that is a type of sleep disorder that is called myoclonus. So, as you are drifting off into sleep, your stage one sleep is eventually going to transform into this stage two sleep. Now, stage two sleep still has these theta waves. I'm still producing the theta waves. But now my theta waves have two unique characteristics. And this is how I know that I've gone from stage one sleep to stage two sleep. And that my stage two sleep, I have the emergence of right here. This is known as a sleep spindle. and it's a burst of neural activity. So, yeah, my brain is starting to slow down, but I'm in this very much transitional stage of sleep where I have this sudden burst of electrical energy that's taking place. And then I'll have, this is the next characteristic, this big wave right here that has a really high amplitude. And this is called a K complex. And a K complex is a random slow period of sleep. So that's why the wave is so much larger, because all of a sudden my brain activity slowed way, way down. And then it's going to kind of maintain this more of a slowing period. So this stage 2 sleep is very much a transitional sleep. When a person's in stage 2, they could easily move out of this stage and wake back up, or they could go deeper and deeper into sleep. So it's going to kind of depend on what's happening in their overall night of sleep. But they're in this stage 2 sleep where from here they could either wake back up again or they could, in fact, go into a deeper stage of sleep. So, this stage 1 sleep and stage 2 sleep are both going to be categorized by theta waves, but the theta waves in stage 2 sleep produce those sleep spindles and those K complexes. Now, let's say that this is a normal night's sleep. You've just put your head down on your pillow. You're starting to fall deeper and deeper into sleep, and you're going through what's known as an NREM stage, or these non-rapid eye movement stages. You've gone from stage 1 sleep to stage 2 sleep, and now, of course, you're moving into stage 3 sleep. Now, stage 3 sleep is categorized by the emergence of a new type of wave. And these waves are known as delta waves. And they are delta waves because now I have moved into my deep sleep. The delta waves, as you can see, are going to be much larger than your alpha and your theta waves, and they're also going to be more evenly dispersed. They're kind of evening themselves out, and you can actually see that right here very well. These are your delta waves. And it's also sometimes referred to as slow wave sleep because, of course, my brain activity has slowed way down. And that's why it's referred to as this deep sleep, because this is going to be that real heavy kind of sleep where it's very difficult to wake this person up, that their waves are demonstrating this slow period because the brain activity is very, very slow. So my brain is really slow, and this is the point in time during my night that my body is going to rejuvenate itself. This is the really important task that's taking place in this stage 3 sleep, is that my body, this is when all of my tissue, my muscle, my skin, all of those kinds of things are really repairing themselves and getting themselves where they need to be in order for my body to continue to live. And so this is the real important task of stage 3 sleep. Now, previous researchers used to identify a stage 4 sleep that also had the delta waves, but these were more evenly dispersed delta waves. Our current research now just really combines this stage 3 and 4 and referring to it as stage 3 sleep. That stage 3 sleep, we have those delta waves, they're evenly dispersed, and they are very, very slow. Now, of course, the next stage of sleep that most people think that we're going to go to is REM sleep. And that's not entirely true. That's not exactly what's going to happen next. But we'll talk about REM sleep and then look at how the pattern goes. So these stages that we've been talking about are all referred to as NREM, or non-rapid eye movement. But REM sleep, of course, is going to stand for rapid eye movement. And of course, the reason why it has its name is because my eyes are going to be rapidly moving in my head. So, REM sleep is notorious for being the point in time where during my night I'm going to have my vivid dreaming. Now, it is entirely possible to dream at any given point in time during your night's sleep, and that you can dream during those NREM stages of 1, 2, and 3. But the kinds of dreams that you are more likely to remember, the kinds of dreams that are more bizarre and they have more of that story like quality, those are all taking place in REM sleep. And so that's really what we characterize REM sleep as having, is that more vivid, more story like kinds of dreams are taking place during REM. Now, here's a really interesting thing about REM sleep is that REM sleep is going to cause a state known as atonia, or it's sometimes referred to as a sleep paralysis, because that's in fact what is happening, is that my body is frozen. My body is unable to move. I cannot move my muscles. Now, what might be happening is that if you were to see a person who's in REM sleep, well, first of all, you would notice that their eyes are moving or rolling around in their head, and that's very visible, where you can see the eyes moving back and forth underneath their eyelids. And in fact, the eyelid might even open up just slightly as that eye is kind of rolling around. And it appears as though the person is looking at something or watching something, when in fact, they are. And what are they watching? They're watching their dreams. For people who have normal vision, that your dreams often take on the form of visual information. You're watching things happening in your dream. And in fact, the body and brain don't necessarily realize that this is a dream. This isn't really happening. And so the body is responding as if these things that you are seeing in your dream were in fact real. And so that's where your eyes are moving around like that. But if you think about it, acting out your dream would be really, really dangerous for you. I mean, I know that I have dreams where I'm running, or I'm even flying, in fact, in my dreams, and that probably wouldn't be a good idea for me to run around my bedroom at night while I'm in fact sleeping. And so the safety net that your body has is this state of atonia. And in fact, this is regulated in the brainstem by parts of the brain such as the pons or the reticular formation, that there is almost like a switch in that brainstem that's going to prevent all of those muscle actions that would take place from the cerebellum and the motor cortex from reaching the skeletal muscles of like my arms and legs. So sometimes little bits of neural activity do make it to my muscles, and it comes in the form of like a small twitch. And so if you ever see a person kind of twitching in their sleep, their muscles aren't completely moving, but their hands or their arms or legs are kind of twitching a little bit, that's how you know that person is dreaming. You can see that that person is dreaming, and in fact, that is a REM state. They're not fully moving. And in fact, you can usually see this really well in animals, particularly if you have a dog at home and maybe you're watching your dog, and your dog is kind of giving these little woofs, and their paws are twitching a little bit, and you just know that they're having this dream about chasing a bunny or a squirrel or something like that. But your dog's not actually running around chasing a bunny or a squirrel that it's seeing in its dream, because that could be really dangerous for it. So that's all that's happening during REM sleep. You have this sleep paralysis, this state of atonia. You're having this really vivid dreaming, and that you're not moving. You're almost forced to watch these dreams that are taking place. And in another lesson, we're going to talk about what are different theories about why dreams occur and that sort of thing take place. But before we do that, we're going to look at then what does a sleep cycle actually look like? Okay, so interestingly, sleep cycles for almost all people, and this is also going to be true for your mammals and even some birds, they're going to go through these sleep cycles that every single cycle takes approximately 90 minutes to complete. So, this ultradian rhythm that your body goes through, a multiple cycle rhythm that takes place, that includes your sleep cycle, and it takes place in approximately a 90-minute cycle. So you start out by being awake, and you lay down in bed and you're resting, and you drift off into that stage 1 sleep. So you're in this stage 1 sleep, and you're probably going to be in this stage for, again, 30 seconds to about 10 minutes, and then you go into a deeper stage, that transitional stage of stage 2 sleep. And now in your stage 2 sleep, you're going to be here for approximately 20 minutes or so. So this is about the first maybe half an hour, maybe 15 to 30 minutes, something like that. And then you go into that deep stage of sleep, that stage 3 sleep, that really deep, slow wave sleep. But then from here, you're going to start waking back up again. And so you go back to stage 2 sleep, that transitional stage where it's now the theta waves, you're having those sleep spindles and the K complexes. And while we don't actually wake up, we now go to a period of REM. And now notice how REM is very close to this being awake, and that's because the brain is very active during REM sleep, and it would appear that the person is awake when in fact they are dreaming. They're having this REM sleep. And this is why it's often very easy for a person to wake up while they are dreaming, because they're in this REM sleep. It's very difficult to wake up the person who's in this stage 3 sleep. And so thunderstorms and trains and things like that might go by, and nothing wakes them up while they're in this stage 3 sleep. Whereas when they're in this REM sleep, it's going to be pretty easy to wake them up. And now a whole 90 minutes has gone by. And then the pattern, well, it starts all over again. Now, notice we skip stage 1. We don't go into stage 1 here because I'm still asleep. I don't need to. And now I'm going to go into stage 2 again. But you'll notice that this stage 2, it's a little bit longer than it was here. And now I go back into stage 3. And this stage 3, it's not quite as long as it was this first time around, and now my stage 2 is a little bit longer, and then I have a period of REM. Now here in this particular person, they've woken up after this stage, after this REM period. That's pretty normal. Some people think that in order to have a good night's sleep, they should never wake up at all in the middle of the night, and that's just not quite realistic. It's pretty normal for the body to wake up after a REM period has taken place. This might be where you look over at the clock, or you roll out of bed and you go use the bathroom, you get a drink of water, something like that. But you should be it should be pretty easy for you to just fall back asleep, and this should only be like a few minutes. You can see right here, it's not a very long period of time in which you're awake. You go back to stage 1 because you were awake. But again, not a lot of time there. And here, spending more time in stage 2, less time in stage 3. And now you'll notice that now my REM period is starting to increase. And then again, as my night progresses, I'm spending less time in stage 3 sleep and more time in REM sleep. Whereas in fact here in this final fifth cycle of the night, I'm not even going into stage 3 sleep. Instead, I'm going into this really long period of REM. So here's what's going on. That while my body is repairing itself during stage 3 sleep, the REM cycle, the REM period, is when my mind is rejuvenating itself, when my mind is repairing itself. Studies will tell us that people who have these significantly longer chunks of time spent in REM periods, they are much better at their memory recollection, being able to recall more information. They also demonstrate greater strides in things like creativity and problem solving, all skills that take on a significant more mental power, a stronger cognitive ability, and that's all associated with these long periods of REM. Now, my body, of course, it needs to repair, but my mind also needs to repair itself as well, and that's not happening unless I get these really long periods of REM that have taken place in these longer and longer cycles that I have while I am progressing throughout my night. So the idea about like, well, how much sleep does a person really need at night? You know, we talk about averages, like 8 hours, an average 8 hours for an adult at night, or 9.25 hours for a teenager. And I know plenty of teenagers who are like, oh, it's fine, I can get by on 3, 4 hours of sleep a night. And it's like, well, yes, your body can get by because your body is getting this, deep sleep sort of a thing. But that mental capacity, that mental fogginess that tends to happen when we only get a few hours of sleep at night, well, here's the reason why. The reason, of course, is that I'm not getting those nice long periods of REM. Okay, and again, that happens with those 90-minute cycles that are taking place. Now, I always get questions about napping and is napping beneficial and that sort of thing. And my argument, of course, would be yes, that anytime that you're getting sleep, that that's going to be really helpful to you. And so, of course, there's a lot of research about what is the ultimate nap time, what's the best amount of time to nap. And here's my suggestions for you. It's based a lot on your sleep cycles. That if I don't have a lot of time to nap, then I'm going to only want to nap for maybe about 30 minutes or so before I really get into this long stretch of deep sleep. Because waking a person up in this deep sleep, not only is it very difficult, but they're going to feel pretty bad when they wake up here in this deep sleep. So if I can't do like a 30-minute nap where I would end where I'm in stage 2, I should go all in and do a 90-minute nap. Do a nap for an hour and a half. And by doing a nap for an hour and a half, then I'm actually completing one full cycle. Or I'll have students who are like, they'll come home and they say that, they took a nap after school for 3 hours. Well, you completed 2 sleep cycles, and that's why your nap was 3 hours. And so it kind of depends on, your goal for the nap. How much sleep do you really need? And speaking of how much sleep does a person really need, your body will actually begin to calculate your sleep needs in what's known as your sleep debt. So if we talked about how much sleep an average person needs in a week, okay, a 7-day period, if we need 8 hours of sleep a night in a 7-day period, a week period, that means that we need to get 56 hours of sleep in that period. And if a person were to say only get 53 hours of sleep in that 7 day period, well, they have a debt of 3 hours, and the body wants you to repay that debt. And how does it want you to repay that debt? Well, obviously by sleeping. And so, what it's going to have you do is things like sleep in on the weekends or to take a nap, and that you are attempting to make up that sleep debt. And I always hear it from students where they'll sleep in on a Saturday and they'll say like I woke up and I felt awful. I was still so tired even though I slept for, 10 hours that night. I'm still so tired. Well, the reason why you're still so tired is because you still have sleep debt to pay off. Or you took a nap and you woke up from the nap and you feel so tired from that nap. Well, you still have sleep debt to repay. And your body knows that, and that's why it still feels tired. But your body can't just sleep for, 24 hours at a time because it has other bodily maintenance activities that it needs you to do. It needs you to go to the bathroom, it needs you to eat. Okay, it needs you to do these other things besides just sleep. And so that's where, when you're amassing all of this sleep debt, it's keeping track of that for you. Now, the good news is that your sleep debt typically recycles approximately every 2 weeks. So, like, you might be having this massive amount of sleep debt, but your body's going to kind of recycle itself or recharge itself and, kind of wipe away your sleep debt, and then it will start building back up again. So, a person who gets the amount of sleep that their body needs every night, they're not sleeping in, and they're probably not taking naps because their body doesn't need them to, because they're getting the amount of sleep that they need in those sleep cycles. And again, this is a really difficult thing for people to do, especially in our modern society where, they don't have 8 hours to devote to these 5 cycles of sleep every single night. And so, again, that goes back to the priority of health, and that sleep is, of course, something that we desperately need to do, that it's important for us to maintain a healthy lifestyle, to get good quality nights of sleep, and to do our best to um, not develop things like sleep disorders and that sort of thing. So we have this maintenance of good health based on our sleep. So today we have talked about the NREM cycles of stage 1, 2, and 3. We've talked about REM sleep and what those waves look like. And next we're going to be looking at sleep disorders. Until then, have a great day.